everyone, welcome back. It's great to have you here to do some revision on functions. We will be going through some examples together, so please get your pen and paper ready and work through these questions with me. First, let's look at this maths machine. So if the input is 1, the output is 1 times 2, which will be 2. If the input is 3 times by 2, the output is going to be 6. Similarly, if the input is negative 5, the output will be negative 10. Now, if the input is x, the output will be 2 times x, which is 2x. And if the input is 3x times 2, that's going to be 6x. If my input is x plus 1, 2 lots of x plus 1, that's going to be 2 bracket x plus 1 or 2x plus 2. In maths, what we can do is to write this maths machine using functions. So I will just call my function f. And what f does is take x in and output 2x. Now, this doesn't mean that all the f function will be doing this. So f function could be taking in 2 and output x plus 2. It depends on the question. Another way to write it would be f bracket x equals to 2x. Now my x is going to be my input and my 2x is going to be my output. So for example, if I have 1 as my input, f1 is going to be 2 times 1. And then f3 is going to be 2 times 3 equal to 6. I have a few more examples here to help you to get the idea of functions. Now if I put in a, the output is going to 2 lots of a, which will be 2a. And as you can see, the function machine on the left is the same as function machine on the right. They will give the same answer. We just represent it in different ways. Now let's do an example together. Imagine now I have machine A, and then machine A does this. It subtracts 5 and then multiply by 3. And I have another machine. It does multiply by 3 and then subtract 5. Now machine C, I will write it in function notation. So Cx equals to x plus 5 over 2. And now dx is root of 2x take away 3. Now if we wanted to represent it using bubble diagram, using function machines, what we have is I'll call my input x. I subtract 5, that gives me x take away 5. And then I will need to multiply everything by 3. So then I'll have 3x take away 5, x take away 5 in the bracket. Or if I wanted to expand it, I'll have 3x take away 15. So that means ax is 3x take away 15. Now let's look at machine B. So now machine B takes the input x, times that by 3 is 3x. And then subtract 5 from 3x. So that will give me 3x take away 5. Now let's look at function C. Now we will need to work out what the order is. As we can see, x needs to be added by 5 first. And then that will give us x plus 5. And then we will need to divide it by 2. So that will give us x take away 5 all over 2. Let's look at function D. X will be multiplied by 2 first. That gives me 2x. And then subtract 3. After that, I need to take square root of everything. So now let's look at function C first. If the input is 2, what is the output? And then please double check, see if you're happy with this answer. Now I can write it as C2 equals to 7 over 2. Let's do a couple examples. If the input is 11, the output will be 8. And the input doesn't have to be a number, it can be an expression as well. So for example, if I have 3x take away 5 as my input, what I needed to do is to add 5 to that expression, and then that will give me 3x. After that, I need to divide that by 2, so the output is going to be 3x over 2. Now let's have a look. 3x take away 2 is actually function B. So what I have done here is I put in a function machine B into machine C. So to write it, what I can write is C bracket bx. And then that equals to 3x over 2. Now what happened if I wanted to find CAX? So that means I wanted to put AX into function C. Now AX is 3x take away 15. So what machine C does is add 5 to that expression. That will give us 3x take away 10. And then I will need to divide it by 2. So that the answer will be 3x take away 10 all over 2. Okay, so now what happened if I wanted to find dBx? Well, bx is 3x take away 5. And then what machine D does is I will multiply my input by 2. And that should give me 6x take away 10. And then subtract 3 from it. So that will give me 6x take away 13. After that, what I needed to do is to take square root. And that will be my output. Is there an easy way to do this? Do I have to draw out the function machine every time? So now let's go back to function C. Now Cx is x plus 5 over 2. If I replace that x with 2, C2 is going to be 2 plus 5 over 2. And that's 7 over 2. It is the same as before when we worked it out using function machine diagram. Let's check a few. making sure we're happy with this. What if my input is 11? See, 11 is going to be 11 plus 5 over 2. And that gives me 8 as my output, which is the same as before. Let's do one more. 3x take away 5. If that's the input, now the old x in the function c need to be replaced with 3x take away 5. 3x take away 5 plus 5 over 2. That should give me 3x over 2. And that is the same as before. Hopefully you have spotted this. Every time you change the x in the bracket on the left-hand side, you will need to change the x with the same input that is on the right-hand side. And when you have a function inside of another function, this is called composite functions. Now moving on to inverse function. So now here we have a function c and function d from before. Inverse function, it has a notation, it's a little -1 at the top of the function. Now please don't say f to the -1 because it is incorrect. What you will say it's the f inverse. That means the inverse function of f. So if I need to find the inverse of cx, that means c inverse. What I need to do is I need to undo what I have done to the input. For example, the inverse of dividing by 2 is multiplying by 2. The input x becomes 2x. The inverse of add 5 is going to be subtract 5. So the final answer is going to be 2x take away 5. Okay, now what we want to do is to check, see if this is correct. So if I have the input into cx, 15, the output is going to be 10. So that means if I need to do the inverse, if I go backwards, input 10, I should have the output to be 15. And as we can see, this is the case. So we can be sure that we've got the correct answer. Now let's look at dx. What is the inverse of dx? The inverse of square root is square. The inverse of -3 is +3. And then the inverse of times by 2 is going to be divided by 2. So our d inverse is going to be x squared plus 3 over 2. Again, let's check the answer. So if the input is 11, d11 is going to give us square root of 19. To check it, now we need to make sure d inverse root 19 will give me 11. And as we can see, that is the case, so we've got the correct answer. Let's just summarize. What are the inverse operations? So we know from primary school, the opposite, the inverse operation of multiplying is dividing. The inverse of adding is subtracting. The inverse of square root is going to be square. The inverse of cube root is going to be cube. Now there are two special ones. The first one is reciprocate. The inverse of reciprocate is itself. And also the inverse of subtract from is subtract from. So these two stays the same. Okay, now let's look at this example. fx is 2 over x. So how would I represent it using a function machine diagram? So many people will just say, well, the input is going to be x, and then I do 2 divided by, so then that will give me 2 over x. Now let's check, see if this is correct. Now, what is the inverse of 2 divided by? Is it times by 2 or 2 times? Let's have a look, see if that will give me the same answer. Now, if x is 4, the output of f4 is going to be 2 over 4, which is a half. Now, what is the f inverse of a half? Will that be 4? Now, I do a half times by 2. That gives me 1. These two numbers don't equal to each other, so I know this is incorrect. Okay, so what does 2 over x mean? It can be written as 2 times 1 over x. So if I have x as input, I'll need to reciprocate it. That's going to give me 1 over x. And then I will need to multiply that by 2. 2 times 1 over x is 2 over x. Now let's check, what is the inverse of that? Times by 2, the inverse is divided by 2. And then we know reciprocate is going to be reciprocate itself. So x over 2, reciprocate that is going to be 2 over x. Now you might be thinking, why this is the same? Have we made any mistakes? Let's have a look. So now we know f4 will give me a half. Now, what is f inverse a half? F inverse a half is going to be 2 over a half. 2 over a half is 2 divided by a half. Divided by a number is the same as times by its reciprocal. So that means 2 times 2, which is 4. And then we can check the output of f inverse is the same as the input of fx. So that means we are getting the correct inverse function. A second example will be gx. Gx equals to 2 take away 3x. With this one, x is multiplied multiplied by 3 is subtracted from 2. So that gives me 2 subtract 3x. Let's look at G inverse. As we mentioned before, subtract from, the inverse of that is itself. So subtract from 2, the inverse is going to be the same. So I have 2, take away x. And then the inverse of times by 3 is going to be divided by 3. I will have x. So subtract from 2 divided by 3. So let's check. If x is 5, G5 is going to be negative 13. Now G inverse negative 13, well, that gives us 5. And as you can see, it is 5. So that means we've got the correct G inverse. Let's do one more example. I would suggest you to have a go at this yourself. See if you are able to apply the knowledge to solve this problem. First, we are given that mx is 2x. nx is x squared plus 2x plus 4. So now let's find m and x. That means putting n inside of m. Well, what m does is m times the input by 2. So if the input is nx, what I need to do is to times nx by 2. And the answer should be 2x squared plus 4x plus 8. The next question is to find the inverse of n. So nx is x squared plus 2x plus 4. As we can see, there are two copies of x squared and also plus 2x. So what I need to do is to complete the square. By completing the square, I will be able to write the equation x squared plus 2x plus 4 as x plus 1 squared plus 3. So now we will be able to draw a diagram for this. The input is x being added by 1, that's x plus 1, and then I'll square them. After that, I'll add 3 to it. So now what we can do is to find the inverse. Add 3 is take away 3 as it is inverse operation. So x take away 3 and then square root it. After that, I will subtract 1. So our final answer will be x take away 3 square root it and then take away 1. Okay, that is it for today. Well done for making through to the end, especially if you have done the question yourself. Remember, maths isn't a spectator sport. We have to keep practicing. Happy revising, and I'll see you in the next video.